Okay, so as mentioned in the email this video is attached to, a roller coaster includes a vertical circular loop of radius 20 meters. What is the minimum speed at which the car must move at the top of the loop so that it doesn't lose contact with the track? Well, a roller coaster car moving around a vertical loop is going to be in non-uniform circular motion, so its speed decreases on the way up and increases on the way back down. However, it is moving in a circle and has a radial acceleration component, and as long as it moves in a circle, it will have the radial acceleration component. The only forces acting on the car are gravity and the normal force of the track pushing the car. And even if the frictional or drag forces are present at the top of the loop, they act in tangential direction, and they don't really contribute to the radial component of the net force. But at the top of the loop, the track exerts a normal force on the car as long as the car moves with a speed great enough to stay on the track. If the car moves too slowly, it loses contact with the track, and the normal force is going to be zero at that point. Well, the normal force exerted by the track on the car at the top pushes the car away from the track in a downward direction, and the normal force cannot pull up on the car. And then at the top of the loop, the gravitational force and the normal force both point straight down toward the center of the loop. And that's all shown in my force body diagram for the car, which is right there. And then from here, I was able to go on and use Newton's second law to continue to solve this. And that is the sum of the forces sub T is equal to M plus mg is equal to ma sub x is equal to mv squared top divided by the radius. And then I manipulated it to read n is equal to the mv squared at the top divided by the radius minus mg. And the mv top stands v top stands for the speed at the top, and in this expression n stands for the magnitude of the normal force since n is greater than or equal to 0. So we can apply this formula then, which is m times v squared top divided by the radius minus g is greater than or equal to 0. And that simplifies down to v top is greater than or equal to the square root of gravity times the radius. And then knowing that, I can find the minimum speed at the top using this formula right here, which is v top is equal to the square root of gravity times the radius. And then all I did from there was plug in my numbers, and I got 14 meters per second.